Okay, so we are going to see today about photovoltaic or solar cell. So first we will see about photovoltaic cell, then we will see about solar cell. And again, we have been seeing about special semiconductor devices in this unit. So yesterday we have seen about the diode, photo transistor, optocoupler. So what all special semiconductor devices that are used in specific applications, we have seen those devices in the last few classes. So now we'll focus on photovoltaic or solar cell. So as you know, the this device is going to work on photovoltaic effect. So you know what is photovoltaic effect? Photo means light, voltaic means voltage. So I'm going to have a conversion of energy happening from light energy to electrical energy in the form of voltage. So this is photovoltaic cell, and this device needs light to function. So if you take a normal PN junction diode, if it is open circuited, and if I'm going to use light to create a potential difference between the different layers and produce voltage, I'm going to call that as photovoltaic effect. So PN junction diode, I'm not going to give any electrical connection to the PN junction diode. I'm going to focus light on the depletion region, and that is going to create a potential difference which is proportional to what is the amount of incident light on the region. So this effect is called as photovoltaic effect, and this effect is actually used in all your solar panels. So solar panels generate electricity from sunlight, right? So without any external power supply to your solar panels, they when light is going to fall on those solar panels, these solar panels generate voltage. So a small one solar panel generates a very small amount of voltage. So I need to have multiple solar panels in series. You know that voltage gets added in series, right? So for that only, I'm connecting all the solar panels in series. So the total voltage obtained from all the panels are additive, and the net voltage will be very high. So that's why in houses and all, you will see they will not have a single solar panel. They will be having a series of solar panels because you need to generate larger amount of voltage. And this the main difference between photodiode and solar cell. So the main difference is in a photodiode, you need power supply. The diode has to be in reverse bias, and then you have to focus light on the depletion region. But these solar cells, they don't need biasing. So as and when natural light is going to fall on these devices, you are going to set up a potential difference. Okay, so that potential difference is what we call it as voltage. Okay, so it produces photovoltaic cell. It's a special semiconductor device which is light sensitive, and it is going to produce a voltage when I'm going to illuminate the diode with a small when I'm going to illuminate the diode with light. Okay, so you know law of conservation of energy means the energy cannot be created nor destroyed, right? You have to transform the energy from one form to another. So here I am transforming the energy from light form to electrical form in the form of voltage, and the voltage produced by the solar cell can be used for small applications where you need that voltage. And remember, the voltage produced by the solar cell is DC. It is direct voltage and it is not alternating. So it is a constant voltage having a constant magnitude. It is not sine wave. Sine wave means it is continuously varying. It is AC voltage, right? So remember, always remember the photovoltaic cell or solar cell, which is going to operate on the principle of photovoltaic effect, is going to produce DC voltage. So this will be constantly asked in your interview questions. They will try to confuse you. We are going to generate power, so they will ask the output voltage of photovoltaic cell is AC. They will try to confuse you by saying that, but no, the output voltage of photovoltaic cell is DC in nature. And if I want to use that DC power in all my household appliances, then I have to have a device to convert the DC power into AC power. Okay, so please understand the difference. So the photovoltaic device without any applied voltage, words are very very important. In photodiode, I have to keep the diode in reverse bias, plus I have to focus my light. But in the photovoltaic device, I need not apply any biasing to my device. So as and when I illuminate light in the depletion region of my device, I am going to generate a voltage. and that voltage depends on two things. One is how much light I am going to uh, illuminate the surface, and second one is what is the load I have connected to my circuit. You know, when the resistance is very high, the current will be less, right? So these two will determine the amount of voltage which is generated from the photovoltaic cell. So the voltage is generated by the accumulation of carriers produced by the photon excitation. So you know, photons will excite the electrons which are in conduction valence band to go to conduction band, and those electrons flow from the photovoltaic cell to produce current. And if you connect a load resistance, you can get output voltage from the load resistance. Okay, so this is the principle of photovoltaic effect. And see that the photovoltaic potential is the voltage at which the zero current is obtained under open circuit. Under normal condition, when the PN junction diode is open circuited and no current is going to flow, the current is no current is going to flow, so the current is going to be zero. So if the current is zero, then the voltage is also going to be zero. So you call that as open circuit condition. So the photovoltaic EMF is zero point 0.5 voltage for silicon or selenium cell and zero point 0.1 voltage for germanium cell, and the short circuit current is in the order of 1 milliamperes. So this is the parameter of a single photovoltaic cell. A single photovoltaic cell made up of silicon can generate 0.5 volt, or selenium can generate 0.5 volt, whereas it is 0.1 volt for germanium. So germanium generates a very small amount of voltage, whereas silicon generates 0.5 voltage DC voltage when the PN junction diode is illuminated with light. And the current equation, you know, it is given by I is equal to Is plus I naught e power into 1 minus e power V by eta into Vt. So here you can say that I am the what is the maximum voltage I am going to the maximum voltage the cell can be generated. So maximum voltage is got when the diode is open circuited. Open circuited means you have to put I is equal to 0. So if you rearrange this equation, putting I is equal to 0, so you replace V by V max and you get the maximum voltage V max equal to eta Vt into 1 plus Is by I naught. So Is, you know, it is the reverse saturation current, which is very much larger than I naught, and V max will increases logarithmically with the short circuit current. So Is is the short circuit current which is flowing because of illumination, and I naught is the reverse saturation current. Okay, so you can see here Vmax depends on logarithm. So Vmax is logarithm of Is. Is is the short circuit current which is flowing because of light illumination, and that value of Is will be very large when you compare to I naught. Reverse saturation current will be in the order of microamps or nanoamperes, but this short circuit current will be in the order of milliamperes. Okay, so the voltage increases as the intensity of light falling on junction also increases. So you can say that as the more light you are going to focus, the more voltage is produced across the semiconductor junction. So the photovoltaic cell is generally made up of silicon, germanium, or selenium, which is bonded to a metal plate. And the symbol of photovoltaic cell is given by the we can see the symbol of photovoltaic cell. So it is generating a constant DC, right? So you will draw a battery symbol with the light falling on it. So this is going to be the symbol of photovoltaic cell, and you will not have the photovoltaic cell as it is. You will be bonding the semiconductor material to the metallic surface. So as shown here, you have a metal layer followed by semiconductor layer. So you have a metal layer followed by the semiconductor layer. Okay, so that is what is given here. The photovoltaic cell will consist of a piece of semiconductor material, which can be either made of silicon or germanium or selenium. You are going to bond that to the metallic plate. Okay, and this is the circuit. It generates a constant DC voltage. So you draw a DC voltage battery and you encircle it, and you assume that you say that the light is going to fall on it. As the light is going to fall, it is going to generate